This is the second set of notes in the oceanography unit. It's called ES 10.2 Ocean Currents. As always with this set of notes, you'll be writing down everything in orange text, either by handwriting it, typing it out, or using my fill-in-the-blank option. In any event, it goes in your digital science notebook when you're done. Pause the video if you need more time. Let's get to it. The main way that energy moves around the ocean is convection. That's warm water rising and cold water sinking. Warm water is less dense than cold water, so it tends to rise, while cold water tends to sink. Same thing happens in a room with a heater. Warm air rises in the room and cooler air sinks, and you get a miniature convection current going in a room. And it's all about density. Warm air is less dense than cool air. And the same thing happens in the atmosphere and in the mantle. But right now we're talking about the ocean, and it happens in the ocean. Water is generally warm near the equator and cold closer to the poles. But the constant convection, along with global wind patterns, cause warm currents to move away from the equator and cold currents to move away from the poles. You get a big system of currents that's fairly predictable. And you'll notice that all the red arrows that are representing warm currents are moving away from the equator. And the blue lines that represent cold currents are moving away from the poles. This creates a constantly moving, complex network of ocean currents throughout all oceans. Because warm water is less dense, warm currents also tend to move on the surface, while cooler currents tend to move below the surface, as you can see in the diagram. Here's a closer look. Surface currents tend to be warmer. Deep currents carry colder, denser water. The network of ocean currents is sometimes called thermohaline circulation or the global conveyor belt. Thermo for temperature and haline for salt. Some seawater is saltier than other seawater, and so increased salt content also makes seawater more dense. So that influences the nature of this circulation. This whole global conveyor belt is essential for regulating temperature and salinity, moving energy, and redistributing nutrients. The Gulf Stream. The Gulf Stream is a warm current that moves away from the equator, beginning near the Gulf of Mexico, across the northern Atlantic towards Europe. The Gulf Stream causes a warmer climate in Europe. So some of those countries are milder in climate than you would expect based on how far north they are. In this diagram here we see upwelling. Upwelling occurs when a cold current brings nutrient-rich water towards the surface. Areas of upwelling tend to have lots of biological activity. Upwelling happens along coastlines where currents run into the continental shelf. If you take a look at these ocean currents, you'll notice that many of them curve. But why do ocean currents curve? The direction of ocean currents changes because of something called the Coriolis effect. Coriolis curves ocean currents to the right in the northern hemisphere and to the left in the southern hemisphere. It's all about the spinning of the Earth. The currents also can become deflected when they encounter continental landmasses. And these curving currents create something called ocean gyres. You can see there's a gyre in every ocean, sometimes more than one. An ocean gyre is a large system of circular ocean currents. There are large gyres in the North Pacific, South Pacific, North Atlantic, South Atlantic, and Indian Oceans. The circular motion is caused by convection, global wind patterns, the Coriolis effect, and continental deflection. Here's a bunch of garbage. In the center of the gyre is an area of calm water. In the North Atlantic, this calm area is called the Sargasso Sea. The Sargasso Sea is an ecologically important area for wildlife. But at the center of some gyres are giant patches of garbage. Human trash is carried by wind and ocean currents towards the center of the gyre, and it accumulates there. And that is it for the notes this time. Here's what they'd look like if you typed them all up on one slide. And you can catch up here if you missed anything. Have a nice day.